Hi, I'm Neil Smith, an engineer at Google. Before joining Google, I served in the armed forces as an oceanographer in the United States Navy. I studied engineering at Texas A&M University. Engineers look at the science and economics of building stuff. As a kid, I was always interested in how things worked, and what particularly fascinated me was the adaptations that we had made to live in very harsh environments around the world. One of the harshest environments that people live and work in is the marine environment. I studied ocean engineering at Texas A&M University. Ocean engineering combines the fields of oceanography and engineering so that we can design things that work well in a marine environment. My first responsibility in the Navy was providing aviation forecasts at an air station in Jacksonville, Florida. And I relied on several different types of technology to make sure those forecasts were accurate. We used satellite imagery, which provided us information about clouds, and also we could get derived wind speed data as well, and radar imagery provided by air stations around the country, as well as forecasts and weather observations that were transmitted into a national communications system for forecasting. These bits of information were provided in a special METOC code that we had to learn to translate. And we would take those forecasts and those observations and match them up against what we had predicted for the weather. This ability to predict the future was one of our greatest adaptations. After completing my assignment in Florida, I had the opportunity to go back to school to study applied physics. Applied physics is a useful degree for oceanographers because it gives us the tools to understand the properties and processes in the ocean and in the atmosphere, and the resources to make better forecasts and predictions of conditions for our naval forces. One of my old bosses used to like to say, weather has a kill chain. In no location is this more true than at sea. My next role after finishing my degree was tropical cyclone forecaster stationed in Pearl Harbor, Hawaii. It was a great assignment, and the properties of weather in the tropics are very different than they are in the mid-latitudes, say, in the United States. The weather there is much more driven by wind currents, and instead of using pressure, we used wind to analyze the environment. Every morning, I would analyze a global streamline chart, tracing out all of the different patterns of weather around the globe, from 20 degrees south of the equator to 20 degrees north of the equator. I would use streamline analysis to begin my forecast, looking for areas of activity where there might be tropical cyclone development. I would use that streamline analysis and satellite imagery and observational data provided by my forecast team to confirm whether there was tropical cyclone development. If there was an indicator of development, it was my responsibility to warn our forces around the globe of potential tropical cyclone activity. In addition to providing advisories of any tropical cyclone development, we were responsible for providing warnings when any tropical cyclone developed. Those warnings included a projected storm track and storm intensity going out 3, 4, even 5 days. We were able to make those warnings using numerical models. Numerical models are essentially a global simulation of the atmosphere and any weather systems in the atmosphere. Over the course of my career in the Navy, I saw those models improve dramatically thanks to the work of scientists who were getting a better understanding of the atmosphere and engineers that were creating more and more powerful computers for us to run those models on. Scientists will continue to make discoveries that provide us greater detail and better understanding of the world around us. And engineers will continue to innovate and provide new tools and adaptations to the world around us. I hope I get to continue on this journey for many years, as it's been a great thrill for me to participate in this discovery and innovation process.